Okay, hey, today we're talking about linear programming. We are going to do this in class, so if you want to be a part of the video, please feel free to ask questions. Otherwise, you can always ask questions at the very end. We're only going to do the very first problem here, and that'll be it for today, mainly because there's 4 parts that I want to go over with these types of problems. So linear programming is nice. It's basically taking multiple linear inequalities, graphing them in a real world situation. That's it. Okay? We use it to find maximum profit. Um, and and you're going to see that there's some new vocab. Okay, it's things that you've already seen before. I'm just putting new phrases to it because it is a real life situation. For example, constraints. Constraints are really just the inequalities themselves. And you're going to notice with each of these, there's no less than 3. Get it? No, I said no less. No less than 3 inequalities for each of these. Okay. There's also something called the feasible region. That is literally just the overlap for the shading. Your solution sets. Objective function is what we're maximizing or minimizing. This is the new thing for you. This is what we call the profit function. I'll show you what that looks like as well. Vertices it's very similar to what you learned in geometry, but really what these are just the corner points for where our feasible regions intersect. And the corner point principle, it's short, sweet, and to the point. It's taking those corner points, okay, those vertices, and plugging them into your profit function or your objective function. That's what tells us, how many of an item we can have to get our maximum profit when we go to sell them. There's 4 different steps to these, okay? In most of these problems, I lay it out like step 1, do this, then step 2, do this, and so forth. The first step, write the constraints and graph the feasible region. Step 2, write the objective function to be maximized or minimized. Step 3, find the coordinates of the vertices. And then step 4, evaluate it by taking those vertices and plugging them into your objective function. I'm going to go through example 1 here. I've got all 4 parts split up. I'm going to use different colors throughout too whenever I underline things. That way you know where I'm seeing them. So whenever you do go back through these notes, you have those accessible to you. A small company produces knitted scarves and sweaters and sells them through a chain of specialty stores. The company is to supply the stores with no more than 100 scarves and sweaters per day. The store guarantees that they'll sell at least 10 and no more than 60 scarves per day and at least 20 sweaters per day. The company makes a profit of $10 on each scarf and a profit of $12 on each sweater. Part A says, write a system of inequalities to represent the constraints. I think one of the first things that we have to look at is an index. So let's create an index. We do with every word problem here. And we're going to let x equal the number of scarves. And we're going to let y equal or be the number of sweaters. Now it does give us numbers for these, but because we're doing inequalities, these numbers can vary. Okay, I like that second sentence there. The company is to supply stores with a total amount of no more than, I like that vocab, no more than 100 scarves and sweaters per day. So we have X amount of scarves plus Y amount of sweaters, no more than, so less than or equal to, 100. That's our first constraint. The store guarantees that they will sell at least 10 and no more than 60 scarves per day. So at least 10 scarves. So 10, so scarves greater than or equal to 10, or scarves no more than, so less than or equal to 60. You can also write this, if you wanted to, you could write this as a compound inequality. And it's less than or equal to x, which is less than or equal to 60. I chose to break it up for the sake of this practice problem. It also states that there are at least 20 sweaters per day that are guaranteed. So our sweaters are a y greater than or equal to 20. Once again, I like this type of vocab stuff that they're spelling out here for us. Now let me just highlight this stuff. More than, at least. I'm going to let you know the company makes a profit of 10 on each scarf and a profit of 12 on each sweater. That's something different. Anytime you see the words profit or gross product, anything that basically means that you're making money, that is going to be something entirely different from constraints. So right there's all 4 of our constraints. We're going to go ahead, we're going to graph these in the feasible region. I'm going to color code them based off of what I did previous. And let's go ahead and start. I'm going to start, first off, I've got to note that because this is a real world situation, we are not going to deal with any negative numbers. So we're actually going to be in that first quadrant. I'm also going to scale this by 5s. Each one of these is going to be 5. I'll just put my markers down for every 10, skip 1. Okay, I believe it was, X is scarves. This is scarves, sweaters, give you a second if you're trying to copy any of this down. You don't have to do yours by 5s, but that's what I'm doing for mine. Okay, graphing the feasible region. This first one here, I'm going to solve for y. Y is less than or equal to negative x plus 100. You can also do x and y-intercept if you want to. I figured we'll just start here. Each one of these is going down by 5 and over by 5, so now I'm going to do something unique. I'm not going to shade this until the very end. Okay, so x is greater than 10, so I'll start this at 10. But it also has to be less than or equal to 60. And then sweaters has to be greater than or equal to 20. So hopefully this will show up in the video, but if I'm looking at this, okay, I'm really looking to see, if you notice, the blue line is supposed to be greater than. The orange line is less than, so I have to be in between there. And then the purple is my boundaries left and right. I have to be in between there as well. So really, I'm looking at that region, anything from that orange down, that's going to need shading. This is going to be my feasible region. And my vertices, or corner points, I put it earlier, are where all my feasible regions intersect. And so got this point up here, 1090, 1020, 6020, and 6040. Give you a second if you're trying to copy this down at home. Part C says rate an objective function for the company's total profit. So again, objective function is usually a profit function. Profit of $10 on each scarf and a profit of $12 on each sweater. So P is equal to 10x plus 12y. I'm going to write that down. This is my objective function. I'm going to write it down below. You might think to yourself, well, why do we need this? We need this because of our inequalities. Where we put our vertices, we're actually going to put those in to our profit function and determine how much profit we're going to make or what our max profit's going to be. It's kind of like if you went into any store, really, and you wanted to buy, maybe you wanted to buy like a teddy bear. Okay, and when the teddy bear was $25, you thought to yourself, oh man, I could totally get this. And I'm sure probably about 100 people thought the same thing. So therefore, 25 times 100, $2,500 that the company would make. But then the company thought to themselves, okay, what if I move this bear to $30? I might lose 20 people. I might only have 80 people buy this bear. But if I put the bear at $30, am I still making more money? Okay, or am I going to make less? And that's the basis of all of this linear programming that we're doing. So I'm going to take each of those vertices, 1020, 1090, 6020, and 6040, and I'm going to plug them into that profit function to determine where my maximum profit, like letter D, find the maximum profit, is going to be. 10 times 10 plus 12 times 20. That's going to give me 100 plus 240, so 340. 10 times 90 plus, I'm sorry, 10, back up here, mixing my numbers up. Should not do as a math teacher. 10 times 10 plus 12 times 90. 12 and 9. going to give me 108, so 1180. 10 times 60 plus 12 times 20. So 600 plus 240. 600 plus 240 is going to give me 840. And then 10 times 60 plus 12 times 40 is 600 plus 480, so 1080. And as you can see, finding your maximum profit is going to be here. So max profit is when 10 scarves are sold for $10 and 90 sweaters are sold for $12.